General relativity, step by step. I've been talking about the Friedmann equation. I developed it in CSS 0331. And after some notational changes, we've got a q plus omega r over a to the 4 plus omega vacuum times a squared equals k. And you'll remember that k was equal to plus or minus 1 over r0 squared, where we've taken the uncertainty in the sign and subsumed it into that symbol there, r0 being the radius of the universe. What I'm going to do now is to divide both sides of this equation, divide by a dot of t evaluated at the current time. I guess you could say a dot of t0. Okay, and bearing in mind that the Hubble constant t at the current time is a dot of t0 over a of t0, what do we get? Well, we get a dot of t squared over h of t0 squared equals, well, we've got this term here, we've got omega m over, omega m over a, because we had a cubed here times an a squared, plus omega for the radiation over a squared, I guess it is, plus omega for the vacuum times a squared, plus or minus k. And I'm going to rewrite the final term there, k, I'm going to write as omega, no, I'll use a capital K, omega k multiplied by h of t0 squared, just a notational convenience. So you'll remember that the sign of this determined the curvature of the universe, and now it's the sign of that. All I'm doing is non-dimensionalizing. I'm not non-dimensionalizing it, I'm just writing it in terms of omega so we can have a more consistent approach. Okay, so I'll rewrite the whole of that equation, and now we have got a dot of t squared over the Hubble constant evaluated now squared equals omega k, which is this term here, plus omega m, omega m for matter over, that's an a, plus omega for radiation over a squared, plus an omega for the vacuum times a squared. Oh yes, I've taken the negative sign over to the plus. I was thinking it was minus that equals a constant, but I've taken everything over to the other side equals that. Well, there we are, and that's quite a nice way of thinking about the Friedmann equations. So I'm going to stop there. Stop.